Generics refers to the usage of type parameters, which provides a way to design code templates that can operate with different data types. Specifically, we can create generic methods, classes, interfaces, delegates, and events. First, let's look at generic methods. In this example, we have a method that swaps two integer arguments. To make this into a generic method that can work with any type, we first need to add a type parameter after the method's name, enclosed between angle brackets. The naming convention for type parameters is that they should start with a capital T and then have each word that describes the parameter initially capitalized. In cases such as this, however, where a descriptive name would not add much value, it's common to simply name the parameter with a capital T. Either way, this type parameter can now be used as any other type inside of the method, and so the second thing we need to do to complete this generic method is to replace the data type that we want to be made generic with our type parameter. The generic method is now finished. To call it, we need to specify the desired type parameter in angle brackets before the method parameters. In this case, we may also call the generic method as if it was a regular method without specifying the type parameter. This is because the compiler can automatically determine the type, since the generic method's arguments uses the type parameter. However, if this was not the case, or if we want to use another type parameter than the one the compiler would select, we would then need to explicitly specify it. Whenever a generic is called for the first time during runtime, a specialized version of the generic will be instantiated that has every occurrence of the type parameter substituted with the specified type, and it is this generated method that will be called from this line. Calling the generic method again with the same type parameter will reuse this instantiated method, and calling the generic with a new type parameter will cause another specialized method to also be instantiated. A generic can be defined to accept more than one type parameter just by adding more of them between the angle brackets. Generic methods can also be overloaded based on the number of type parameters that they define. When using generics, one issue that may arise is how to assign a default value to a type parameter, since this value depends on the type. The solution is to use the default keyword followed by the type parameter enclosed in parentheses. This expression will return the default value no matter which type parameter is used.